everyone, welcome to day 10 of 30 days LeetCode challenge. Today we are going to solve three sum problem require us to find all the unique triplets in an array that sum up to 0. Given an array nums, the task is to return all such unique triplet num of I, num of j, num of k such that I, j and k are distinct and num of I plus num of j plus num of k is equal to 0. For that, you can see one example here where in an array -1, 0, 1, 2, -1, 4, the output will be -1, -1, 2 and -1, 0, 1 whose sum is equal to 0. Here you need to remember that we need to add unique triplets only. So to solve this problem efficiently, we are going to sort the array first and then we are going to use two-pointer technique. So here is the plan. In the first step, we will initialize the result and check if nums is equal to 0 or nums.length is less than 3. And then in step 2, we will sort the array. This will help us to simply find and skip the duplicates. In step 3, we will iterate with fixed element and use two pointers to find other two elements. In step 4, we will skip the duplicate. And in the last step, we will return our result. Keeping all of these steps in mind, let's start coding. So first, we will declare a variable result. After that, we will check if nums is equal to null or nums.length is less than 3, then we will return the empty result array. Now, we will move to step 2 and for sorting the array, we will use arrays.sort method. After that, in step 3, we will declare a for loop which will be starting from I is equal to 0 to I is less than nums.length minus 2. Move our step 4 inside the for loop. And for skipping duplicates, we will check if I is greater than 0 and nums of I is equal to nums of I minus 1, then we will continue. After that, we will use two-pointer technique, where we will declare a left variable and initialize it to I plus 1 and the right variable and we will initialize it to nums.length minus 1. Then we will have a while loop which will iterate till left is less than right. And now we will have a variable sum where we will store the addition of num of I, num of left and num of right. Now this sum can be a 0 or less than 0 or greater than 0. So let's have a condition where sum is equal to 0, else the sum is less than 0, else sum is greater than 0. So if the sum is equal to 0, then we will add the triplet to the result. For that, you can use result.add method. Now we will move our left pointer and skip the duplicates. For that, we will have a while loop which will iterate till left is less than right and the nums of left is equal to num of left plus 1. If the num of left and the next element is equal, then it will increase the left pointer. And similarly, we will check for the right pointer. If the num of right and its previous element is similar, then we will move our right pointer. And after skipping the duplicates, we will move our pointer to the next potential element. So we will just write left plus plus and right minus minus. For sum is less than 0, we need a larger sum. For that, we will increase the left pointer. Else, if it is greater than 0, then we need a smaller sum. So we will move the right pointer. Now in the last step, we will return our result. Let's check if everything looks good. And let's try to run the code. Oh, so here we need to have nums.length, not num.length. Now let's try to rerun the code. And it's working fine. Sorting the array helps in using two-pointer technique and easily skipping the duplicates. We skip duplicate value to ensure result contains unique triplet. And two-pointer technique find pairs that together with the fixed element sum to 0. I think this approach ensures we find all the unit triplets in big O of n power 2 time complexity, making it efficient for the given problem constraint. That's it for today's explanation. I hope you found it helpful. Stay tuned for more problem solving insights tomorrow. Happy coding!